Today we're going to look at the concept of volume, and to begin it, let's consider the story of volume with Minds on Math. So here's the question that I'd like you to consider. Okay, looking at the structure below, which I hope is a familiar one, what geometric figures were used in the casting of the molds required to form the poured concrete? Okay, so you might recognize this as the Museum of Civilization in Hull, and it's a beautifully structured building that houses some of Canada's most prized artifacts from across the country. And you can just perhaps appreciate the lines and the contours, the depth that the building itself has. Okay, so previous to this, we were studying perimeter and area concepts. So the concept of area is very closely related to that of volume. In fact, if I were to use the word shape, I would be asking you to consider those objects that are flat. They're what we call planar or two-dimensional. The only way that we arrive at a geometric figure or a three-dimensional figure is by layering an infinite number of very thin sheets or thin areas of a particular shape, and that is what helps it to grow or to gain depth, to have height. And anything that has height or depth has volume. It can be filled, and in this case, filled with concrete. Okay. If you have a moment, just as a side, uh, try searching YouTube and watch some of the primary footages of the building being constructed, and I think you'll be quite amazed at the construction of the Museum of Civilization. So today's lesson is on the volume of prisms, and I'm going to ask that you calculate the volume of a variety of different types of prisms. Okay, the word prism should be familiar to you from past math courses, and you're going to see a number of them today. And I'm also going to ask that you think critically about what's going on behind determining the volumes of non-traditional prisms. Okay, so we'll look at both traditional and non-traditional prisms. So according to what we have here, you have a template that you can fill out. I'm going to give you a couple of key ideas, and then we're going to build the concept of volume from there. So let's fill in a few of these blanks. And the volume of all prisms is determined by multiplying the area of the figure's base by its depth. And sometimes depth is referred to as height. Okay, so you can have a look at question number 1, and we're going to focus on the attributes of base and depth or height. So for each of the prisms in number 1 provided, let's indicate both the base and the depth. Okay, so using these clone labels below, let's start with this prism, which is a pentagonal prism. The reason why it's pentagonal is because the base is 5-sided. Okay, the depth is going to be the length of a rectangular side, which we can see along here. So the volume of that pentagonal prism, okay, is going to be the area of this base multiplied by the depth. Okay, let's have a look at this particular prism. Okay, it's a rectangular prism, and we can identify the base in two different cases. We could refer to this bottom, or the top for that matter, as being the base. Its depth then would be the height. On the other hand, we could look at filling this rectangular prism in a different manner. We could refer to as the side, either one, as being the base, and thus the depth would be this length here. Okay? To the right, we have what we would call a triangular prism. Okay? The base of this prism would be the triangle. Okay? And the depth would be the width of the wall. So I'm just going to indicate that here. So when you're identifying the base of a figure, the easiest way to do it is to ask yourself, which particular shape would I be able to slide along a particular axis so that it fills that figure with the same shape? Okay, so for instance, the pentagonal base, you could slide along the depth and you would still be able to create the same figure. That's true for both the rectangular prism and even for this triangular prism. If we take the triangular base and we slide it through this depth, you're going to notice that an infinite number of triangular sheets are going to map out or trace out the three-dimensional figure. Okay, let's move forward. So in this first video, we'll cover about 10 minutes worth, and then we'll get into part 2 in a separate video. In number 2, for the figures that are provided, what we're going to do now is move into listing formulas, things we would need to get the volume of these prisms. Okay, and I want you to recall that from earlier on, I did mention that the volume is the base area multiplied by the depth, which is also referred to in some cases as the height. It depends on the context. Okay, so for each figure, we're going to look at the base area and we'll identify what that is and a formula that will be used for it. And from there, we'll be able to calculate the volume. So let's consider the pentagonal prism. Okay, remember the base is the pentagon. Okay, and in order to find the area of a pentagon, we can do it in a number of ways. Some of you might have performed this in the gazebo task, where you were able to chunk it into 5 different triangles. Okay, and if it's regular, then the 5 triangles would be congruent or would have the same area. Sometimes it's easier to break the shape into other types of shapes. In fact, we could break that base into a triangle, which we have here, and a trapezoid, which means that for the base area, we would have to calculate the area of a triangle, and to that, we would have to add the area of a trapezoid. Okay? And with that in place, if we were to calculate these two together, okay, I'm going to bracket these amounts here. So if we were to perform these two operations, that is to find the area of both the triangle and the trapezoid, and then multiply that by the depth, we would have the volume of that prism. Okay? And before this video ends, let's determine what formulas are necessary for the volume of this rectangular prism. So the base area, depending on what side you want to use, well, they're all rectangles. So the area of the base would be length times width. Okay? And from there, we would have to multiply that by the depth. Okay? So we would first calculate length by width for the base, and then multiply it by the depth. Okay, so in the next video when we come back, we'll get into calculating the volumes of different prisms.